Unit 5 Forces, Podcast 4 on Moments. So, if you have an object acting on something, the object causing a force, and it causes it to turn, or gives it a turning effect. I'm not sure that effect came out there on the sheet, but giving it a turning effect. If you have a force acting on an object which can cause it to turn, so this, if this is a pivot and this is some idea of a seesaw, and you have a weight here, it could cause it to turn, like in this diagram down below. Then we say that it has a turning effect. So the turning effect of a force is called, and we give it the name, moment. So whenever we're talking about moments, you always have to have this idea of a pivot and some idea of a turning effect. And whenever we talk about a turning effect, it's either, in this case, it's anti-clockwise, or if we had the weight on the other side and it was causing an effect around this way, we would say it is a clockwise moment. And we talk about that as a direction or a sense, the sense that it's going to turn in. So using moments. Here's a couple of examples of moments. A spanner is what we call a lever. And whenever you attach that lever to some kind of nut here, which is very difficult to loosen, you can use your spanner and use a turning effect with your spanner to loosen the nut. So it would be very difficult for you to come along. You probably can't see the nut here. I can hardly see it myself, but it'd be very difficult for you to come along and use your hand and try and turn it. So what we do is try and make life easy for ourselves, and we use a lever to do that for us in the form of a spanner. So the spanner exerts a moment or a turning effect on the nut, or turning force. The middle of the nut will be the pivot, and that will be where the spanner will turn about. You'll pull using an effort or a force here, and we work out the moment by calculating the force and the distance from the pivot here. If the moment isn't big enough, if we grab the spanner halfway down here and we pull it this direction and we're still not having much success, then there are two ways of increasing the amount of moment. And those are, number one, we could increase the distance from the pivot. In other words, you could move your hand down the spanner and apply the force at the end of the spanner instead of halfway down there. So if you apply the same force, but you're applying it a greater distance away from the pivot, then you get a larger moment if you have a greater distance. So that makes it obvious to us that, right, we need a certain amount of moment to get this nut loosened. So if we move our hand a further distance away from the pivot, then we can get away with using less force. So the lever is helping us do work here by using less force, and simply that's by increasing the distance from the pivot. Okay, so using moments then to increase the moment. The second way we can do this is, instead of moving a longer distance away from the pivot, you may not be able to do that, it depends on what you're using. The second option that you have is to increase the force applied. And so if you use a larger force here, the same distance from the pivot, then you're going to produce a larger moment if you use a greater force. Right, the moment equation. So we've already talked about how you increase the amount of moment exerted by a force, and it's given by an equation. And the equation is that the moment of a force is equal to the force that you exert multiplied by the distance from the pivot. Now sometimes you'll see in equations or in books they say the perpendicular distance. And if I just put this back a wee second, I'll put back this one here. If I just put this back a second, you can see that the perpendicular distance is the idea of a right angle between where you're exerting the force and the actual lever itself. So there's a right angle, so that's a perpendicular distance. This distance here is a perpendicular. If we exerted our force at an angle like this or like this, then that wouldn't be a perpendicular distance, this distance here, so we would have to recalculate that in some way. But you'll only be given fairly straightforward examples. So moment is equal to force times perpendicular distance from the pivot. The force is measured in newtons. The perpendicular distance could be centimetres or metres. And so our moment could be measured in, depending on what you measure your length in, it's newtons by centimetres, or it could be newtons by metres or newton metres. We shorten that too. So there's a question here. Gina's standing at the end of a seesaw. She weighs 500 newtons and she is half a metre from the pivot. What moment does she exert? So we'll write down moment equals force by distance. And the moment is equal to her force, which is 500, multiplied by, I'm just going to mark in her distance because sometimes examiners will try and catch you out by marking in the distance she is from the end, and they tell you the length of the seesaw, or they tell you the length of this end of the seesaw or something. So it's always perpendicular distance from the pivot. So half a metre and a half times 500 gives you 250. It's in metres, newtons and metres, so the answer is in newton metres, and there is generally a unit mark for something like that, so don't leave it out.